Okay, last week, last 2 assignments. Can you believe it? I'm ready for a break. I don't know about you guys. Last week we did exponential functions. This week, exponential equations. So, take some notes. Not really taking notes, we're doing a whole bunch of example problems, which is different than taking notes, but whatever. What's today's date? 9th of June, 2020. Dun, dun, dun. There are 1, 2, 3, 4, 5 sections on the assignment, so I'm going to do an example or 2 for each section. So I'm going to call it part A. Example 1. Voila. So this part is the easy part. Like if we give you a problem like this. 9. So it's 3 to what power equals 9. We don't need to see any work. You just write the answer. So 3 to the power of 2. X obviously must equal 2. So all you have to do is go x equals 2. You don't have to check it. Nothing. Just write the answer. Yeah. And there are 1, 2, 3, 4 of those. Next section. Done a little bit harder. So what if we went like this? You know the answer for, if I put 9 here, you know the answer for x is 2. But what if I put something like 20? Yeah. Now, A, you're going to either need calculator or super great estimation skills. So let me show you how to do it without a calculator first, the logic part of it. Yeah. So you know 3 squared equals 9, and you also know, or should know, that 3 to the 3rd power is 27. Yeah. So 3 to the power of x equals 20. 20 is closer to 27 than it is to 9. Yeah. So my estimation would be about let's see, 2.5 would be right in the middle, and 20 is not right in the middle of those two numbers. Plus it's not linear, so it doesn't work that way anyways. But I'm going to go 2.6, because 20 is a little bit closer to 27 than it is to 9. It's only 7 away here, but 11 away there. So I'm going to go slightly bigger than 2.5. And let's see how close I am. 3 to the power of 2.6. Does that equal 20? Of course it doesn't equal 20, but how close is it? Yeah, not too bad. Not too bad. Let me try 2.7. Ooh, 2.7 would have been better. Shoot. Let me fix that. 2.8. 3 to the power of 2.8. If you think in terms of money, right? $19.42 is only about 60 cents away from $20. But $21.67 is $1.67 away. So 2.7 is a little bit better. Yeah. So my initial guess, 2.6, it was pretty close, yeah. So I used logic. This is logic to estimate my 2.6 that I checked on a calculator. So a little bit of both. There are only 2 problems like that. Yeah. C. Oh, that was, call that example 2. We are now on the 3rd part of the assignment and the 3rd example. Okay, these are not that bad. I'm going to do a couple examples for you though, okay? Let's say you have 2 to the power of x minus 4 is equal to 2 to the power of 10. So, these type of problems, as long as the bases are the same, the exponents must be equal to each other. So, and that is pure logic if you think about it. If the bases are the same, then the exponents must be equal to each other. The exponents must be equal, equivalent. That's probably some property. It probably has a name for that property. So as long as the bases are the same, and they both have a 2, then the exponents must be equal to each other. So you get x minus 4 equals 10. Now, there is no work to show. If you try to show work, I guarantee it's going to be wrong. So you go from the original problem to this step, just like that. And don't show work. Don't try to show work. Otherwise, it's going to be wrong. I can almost guarantee it. And then you just solve like normal, okay? Add 4, add 4. If you want to show that, I'll go right ahead. Whatever floats your boat. X equals 14. Which is obvious, right? 14 minus 4 is 10. That's kind of obvious, yeah? But even though it's obvious, we want to see you go from the original problem to this step for sure, because that is a major property when dealing with, oh, I forgot to tell you the name of the lesson, exponential equations. Da 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 da. Okay, and let me do another example, a little bit harder. So it's nice and easy when the bases are the same, but let's say you got something like this. 81. The bases are the bases are not the same. I got a 3 here. I need a 3 over here. So what you're gonna have to do? And yes, I want to see the work. Show me the money. I mean, show me the work. But you don't know what movie that's from. Show me the money. You better not know what movie that's from. Shoot. Show the work. Look at that. Double exclamation point. So, here's what I'm talking about as far as showing the work. By the way, the exponent is 2x minus 5. Make sure you write it as an exponent. So it should be a smaller font and high. Small and high. Like a midget on crack. Small and high. And then you have to change this to 3 to the power of what? 3 to what power? All you're doing is replacing the 81 with something that it's equal to. That is perfectly legal. I know it's not 2, because that's 9, right? I know it's not 3, because 3 to the 3rd power is 27. Let me try to the 4th power. There it is. So 3 to the 4th and 81 are equal to each other, so I can replace 81 with a 3 to the 4th power. Yeah? Bam! Now, this problem is exactly like this problem. The bases are now equal to each other. Oh well. How about a squirrel? Instead of a small and high, I changed my analogy to a squirrel that ate some mushrooms. There we go. That's there. A little bit more politically correct analogy, I guess. So bases are the same. That means the exponents must be equal to each other. Bam. Use lined paper for sure when you do this. Don't print the assignment. Just do your assignment on notebook paper. So A, you have enough room. B, you're able to write things on the proper level. Yeah. And then you add 5 to both sides. Divide both sides by 2. If you want to change it to a decimal, go right ahead. I don't care. Voila. Yeah. So that's part C. Part D, or the fourth part of the assignment. Keep in mind, it gets harder as you go. And wait till you see tomorrow, or the next one, the 11th of June assignment. Hold on to your britches. I'm going to go to the next page, because I know this is not going to be enough room. Part D. I don't know what example I'm on. Example 5. Example 5. Da 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 da. Dun 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 dun. Okay. Here we go. Sorry, doing some calculations. Are you ready? Yep, here we go. So now there's steps, right? First step, let's get rid of that multiplying by 4. How do you do that? You do that by dividing by 4, yeah. And I don't really care if you show me this, because it's first year algebra stuff, but if you want to show it, that's how you show it. The 4's cancel, and then you get 343 to the power of 2x minus 8 equals 196 divided by 4. 196 divided by 4. 49. Alright, now we need the same base. Hopefully, when you see a 49, your brain automatically thinks 7 squared. Yeah. So I'm going to make that into a 7. This is equal to that. Yeah. Now I need to change this to, let's see, 7 to the 0. No. 7 to the 1. No. 7 to the 2. No. 7 to the 3. Maybe. Oh, there we go. We got a winner. So I'm going to replace 343 with 7 to the 3rd. Now, usually when you replace something in algebra, you put the thing that is being replaced inside of parentheses. It's not necessary on this side because there's nothing else on that side. But on this side, since there's already an exponent, watch what I do. Shoot. I'm going to replace that 343 with, so first of all, look what I did. Yeah. Watch this. Okay. Identical, right? All I'm going to do is, instead of 343, I'm going to replace it with 7 to the 3rd power. Bam! What now? And then, it's been a while since we did exponent properties, way back in March. This is the power property. When you have an exponent raised to another exponent, you have to multiply the exponents in order to get rid of the parentheses. So 3 times 2x minus 8 is 6x minus 24. Bam, look at that. Now the bases are the same. and there's no parentheses. So now you are allowed to go or to write 6x minus 24 equals 2. 6x minus 24 equals 2. The exponents are equal to each other. Yeah? And then the next two steps are just first year algebra. At this point, you can, if you want to, but should be able to solve this one step at a time. But in your head, like, add 24, add 24. Bam! Divide by 6, divide by 6. Bam! Or reduce it. Bam! Or change it to a decimal. I wouldn't change it to a decimal in this situation because you're going to get like 0.3333 or 0.66666. So I would just leave it as a reduced fraction. Definitely not a mixed number. Yeah. Let's see. Do we need any more examples other than that? Yeah, I'll do one more. One more example. This is for part D and E, by the way. So, let's do one more example, yeah? 7 plus 64 to the 5 minus 2x is equal to Step 1. Get rid of that 7. You see a plus sign. Well, I guess you shouldn't look at this. You should look at the fact that this is a positive 7. Don't look at that. Don't look at that. That has nothing to do with this 7. My bad. Bad teaching. So the fact that this is a positive 7 means you have to subtract 7. Bam! If that were a minus sign, then you would have to divide by -1 on both sides to get rid of the minus sign. That's why I messed up when yeah. Whew. Okay. 32. Okay. Now we got to figure out how to change this base and this base so they have a common base. If we were in school, one of the days, like the first day of this lesson before we actually started solving, what we would have you do is do all base 2, base 3, base 4, so you would recognize these two numbers when you see them. So, this is what we would have you do in school. We would have you go, shoot, 2 to the first, 2 squared, 4, 2 to the third, 8, 16, 32, 64. Oh, look at that, 32 and 64. We have a winner. 128, etc. And then we would have you do base 3. 3 squared is 9, 27, 81. That's about as far as you need to go right there. And then we'd have you do 4s. 4 squared is 16. 4 cubed is 64. That's about as far as we would have you go with the 4s. 5 squared is 25. 5 cubed is 125. Then we would have you do 6s. And then 7s. I know what you're thinking. How the heck? Because I've been doing this for so many years, I have it memorized now. 512. I have no idea why I know 8 cubed is 512, but it is. 9 is the easiest. I'm an idiot. I said it's easiest and I don't know what to put there. Alrighty then. What the? I'm an idiot. That's what happens when you try to talk and do math at the same time. 9 squared is 81. Now I can do it. 9 times 81 is 729. Okay, anyways. And what you're looking for is a 32 and a 64. 32 and 64, right there. So we know it's base 2. Whoop, come back here. I am allowed to replace 32 with 2 to the 5th. Why? Because that's what 2 to the 5th equals. Yeah. And I'm allowed to replace the 64 with 2 to the 6th. Yeah. But when you replace that 64, because there's stuff outside of the 64, either in the front or as an exponent, you have to use parentheses. This 32 had nothing, had no exponent other than the invisible 1, had no multiplier, no add-in, nothing. So we don't need parentheses right here. We need parentheses right there. So I'm allowed to replace that 64 with 2 to the 6th power. And then this is the power property of exponents. To get exponent raised to another exponent, you multiply them in order to get rid of the parentheses. Voila. And then now that the bases are equal and there are no parentheses, you are now allowed to say that the exponents are equal to each other. Okay? Then subtract 30 on both sides. Subtract 30. Cancel. Negative 12x equals negative 25. And then you divide by negative 12. Divide by negative 12. Cancel. X equals 25 twelfths. Or I don't know if I should change this to a decimal. Let's see, 25 divided by 12. Bam. And nope, I'm gonna leave it. Yeah. All right, that's it. That's the lesson. Good luck. There are 20 of those. Should be pretty quick though, because equations are pretty quick.